For the RISE project, he serves as the WebGIS developer, data curator, field training facilitator, and he is also responsible for liaising um, with the clients and exploring the use of handheld devices in field data collection. In the GIS laboratory, he serves as the managing of the hardware and the software, administering data storage and backup, and he also offers GIS and GPS consulting services. So I will not make this any longer. Let's welcome our guest speaker, Mr. Arnel Rala. The floor is now yours.
Okay, thank you, Hannah, and good afternoon. Uh, I'll be talking about WebGIS of RIICE. It is one of the deliverables in the RIICE project. Uh, this is actually episode 3. Andy has already talked about RIICE in a few months back. Okay, but to get the ball rolling, I'll be discussing on these 3 topics. A brief overview of the RIICE project, the WebGIS concept, and then focus most of my time with the RIICE WebGIS. So the RIICE project, what is RIICE actually? It is remote sensing based information and insurance for crops in emerging economies. It is a public-private partnership and it is ongoing for 3 years. The objective of which is to develop technology for rice crop monitoring and damage estimation. Also to demonstrate low cost and timely insurance solution based on that technology, to build partnership and networks to deliver rice crop insurance solution, and lastly, to obtain government level support for food security applications. So these are the core partners in the RIICE project. IRRI is responsible for calibration and validation of the different of the existing rice crop growth models, and we are also tasked to work with regional partners. SARMAP develops the software and produce the rice products based on remotely sensed data. Allianz developed the insurance solution based on the data that SARMAP and IRRI produce. GIZ convenes aggregator networks and trains them to pass on the solution as microinsurance. And of course, SDC, who provides the funding for this activity as well as organizes the knowledge management of the program. The project won't be successful if we have not take into consideration the participation of our national partners. And this cuts across 8 regions on 7 countries. And they provide us with the expert knowledge, baseline data, field work, and monitoring. So this map shows the different sites where RIICE project is being conducted. There are 6 countries with 13 sites. To summarize the entire activity of the RIICE project, satellite observes rice crops on the field through remote sensing. We derive and field work throughout the season, and this gives us a rice crop status maps. Remote sensing data is linked to crop growth model so that we could have estimated yield and forecasted yield. And this area and yield information are used to develop insurance products that covers the farmers' shortfall in production due to natural disasters. Distribution channels are being identified and trained to roll out the insurance products, and local insurers sells the products through the distributor and reinsures the risk through Allianz-led reinsurance pool. And lastly, this should give a smile to our farmers. Okay. So that's a brief overview of RIICE, and if you have more if you want to see more information, you just visit this site or have a personal chat with Dr. Nelson. Okay. So where is WebGIS? Where does WebGIS falls into that picture? Going back to that previous schematics, WebGIS is here. It acts as a bridge between the technical output and then the insurance packages. What is WebGIS? Okay. WebGIS is basically GIS, or Geographic Information System, or science, as they call it, that uses internet, web, or cloud technologies to communicate and analyze spatial information. In this diagram, we create all the spatial layer or databases locally. We upload it into a cloud server, and then depending on how it was configured, it could serve mainly for web user, the purpose of satisfying web users, mobile user, and hardcore GIS user. Or it could do all three at one time. Why do you want to do this? Well, there are two reasons. On the perspective of a user, let's say these are our client, we want them to use just one source of information. There will be no misinterpretation or miscommunication between informations. And from that cloud or web, we could use that to do other processes or analysis through his desktop or laptop, possibly through a tablet and smartphones. The other reason is that we want to remove or close to eliminating the divide between different data sources. Okay. Hopefully we'll end up with this such that each end user will start sharing and collaborating information. Now we go to RIICE WebGIS. Okay. The WebGIS gives our RIICE partners access to the maps and tabular data. Maps can be visualized online. They could download it, or they could use it directly on their own GIS software. Tabular data as well can be visualized and downloaded. Another reason is to provide information in a quick and timely manner. For instance, if flood does occur and there are damages, why wait for the end of the season for information to come in? So this is our design. So IRRI right now has a license for ArcGIS server, but it is limited for non-commercial purposes. We use that to configure an Amazon Elastic Cloud, Computing Cloud, or EC2. We collect information from our partners, and we build databases out of this information. Then we upload that into the cloud service, where Arc server is. Then we build user-friendly interfaces. Just for your viewing pleasure, this is the configuration of our Elastic Cloud. This is the minimum required for Arc server to run. Okay. One good thing about the Arc server or Elastic Cloud configuration is that it is scalable. We could easily increase it if demand needs the service. Applications that are running are as follows. Aside from Arc server, Amazon, we are also leveraging on Google services, primarily for security, front-end interface, documentation sharing and collaboration, and also means of analyzing stats and visitor hits. So this is a common interface for all of our WebGIS. It has this agreed upon style where linkable pages referring to different elements like the map, user manual, description, data description, and glossary. There are also brandings of our core partners and national partners, and a way to monitor our visitors. But the key important element in this interface is the mapping application. So what are online? We now have 6 WebGIS available for the different countries. So you might be asking, how do I get to this 6 WebGIS? It might be like too demanding of a task to remember all the URLs. So we are designing one to bring them all together, sort of like a jump page. And this would link back to http rice.org. So let me focus now on the mapping application, because this is where the fun part is. Our partners ask us to follow the KISS principle. What is KISS principle? Keep it simple, scientists. Because they are non-scientists. They don't want to complicate their lives. So, oops, go back. Sorry. That's not a way of keeping it simple. Okay, so we have here a mock-up of the actual or the live WebGIS. The common display area where you can magnify, demagnify, move to one part, one side or the other. The layer list, or where all the spatial layers are presented along with their different classes or legends. A set of tools that aids in providing an interactive query on the map display, and ability to change backgrounds. So one of the tools is this, the bookmarks. It allows you a quick jump to a particular site, which is basically the area we are working on. Change backgrounds. Right now we're using topographic, but we could also use imagery, satellite imagery, optical imagery with labels, and of course street map if you are more familiar with landmarks. But one thing that our partners like is what they call the one-click show all information. Okay, that's making it more simple. And this is just an example of that. It shows you location, name of the location, and what other information are there, like land area, rice area, whether it is the start of the season, at what growth stage, and so on. So with WebGIS, scales is not an issue. We could look at it at the national level, provincial level, watershed level, and even at field or, let's say, barangay or field level. Okay. So this table summarizes all the active and operating functions within the different country WebGIS. So you're asking what data are there? Actually, I have already preempted some of the data, but here I'll show you a much detailed view of what data are available. The first three are always there. Partner location with contact name, the satellite footprint, so that our partner or clients would know the extent of where we are working. Administrative layers, we could provide down to the smallest level, which is available. Moving on, these are now results or products derived from remote sensing analysis. The rice extent, rice area, and seasonality maps. An example of which is an example of the rice seasonality map is this, as shown on the screen. It shows at each field the date or approximate date when a particular field was planted. Other information includes rice phenology or growth stages, crop cut experiment, leaf area index, and yield arising from the IRRI-SSD 2000 simulation model. Okay. This is an example of the rice phenology layer. It shows the stage of individual fields based on this classification. majority are flooded, some are still in bare soil. But as we move along through the season, we will notice this field changes in classes. I have cut some corners to shorten the presentation. So, and then we now see harvesting, while some are in senescence or peak tiller. Last two datas are the rice statistics. We extract this from the World Rice Statistics compiled by IRRI. And of course, the summary information layer. This is the basis of that one-click show all function. So where the data came from? Okay, so as mentioned earlier, area and status maps are processed by SARMAP, and they made this available in an FTP site, which on our end, we download this automatically. It's actually semi-automatic because we have to verify the integrity of the data that are being downloaded. LAIC and CEC, or crop cut experiment data, conducted by national partners, are also sent to IRRI. Here we make use of Google's G Drive or Google Drive for data synchronization. It's also a quick way for us to check whether they are submitting on time or there are problems in the data they are submitting. These two, area status map, the LAI and CEC, after some prepping, we now upload that to the ArcGIS. The same data are used to run our RIICE 2000 for yield maps. And of course, the rice crop statistics from the World Rice database are directly uploaded. Insurance information, we have just a subset, not the entire data collection, because this is for this is just a proof of concept, and we want for our partners to see that they could infuse their insurance in such a platform. So this table shows now the summary of all the published data. So these are the data that I've earlier presented. These are the different WebGIS. Those countries with zeros means two things. One is that the satellite acquisition hasn't been conducted yet, or the data are being processed and ready for uploading. In terms of updating, this project will run for 3 years, and each year there will be 2 to 3 seasons. Okay, so the amount of data would be enormous. And we're looking at this set of information to be updated at the end of each season. So, with the exception of rice, if we yield, sorry, if we intend to do forecasting, that will be done twice in a season, mid-season and end of season. Rice statistics are updated annually, or depending on whether there are available information. And then these 4 sets may or may not be updated, or depending on whether there are new information. With all these functions, data, are there documentations available? Yes, there are. And we have produced 3 of them, the most essential ones. Of course, the user manual. We don't want our partners just to play around there and look at good maps. No. Data description, the one I've shown earlier, as well as the glossary of term. Only us scientists would know what this means, so we have to convey to them what we really do. Okay, for a quick demo, hope it works. Yes. Okay. All right. So this is the entire WebGIS of the Philippines. Okay, there you go. So by default, it shows the administrative layer by the first level, as well as the rice extent, the green one. And it is on top of the topographic map. Okay. So this area here shows the layer list. User can click on this arrow to display the information that are underneath the different classes. Baseline. The bookmark served as a jumping point. If it wasn't done order, would just zoom in there. The geolocator, like one of our sites is in Ormoc City. Let's just it would give you a quick jump point as well, and would show it would move the map to that area. Some of the layers are scale dependent so that it would not clutter the display. Some are visible on a certain level or scale level, and it will be invisible at others. The one-click function is this. So it's based on land area, RIICE area, model yield, and so on. Yield trends per season, depending on our RIICE database, World RIICE database. So, of course, you could change. Oops. As I've said earlier, you could change the background information. Zoom in further and see what is underneath. A good way to verify if the RIICE output jives with the optical output. So if this green area is really RIICE or not. Okay. Okay. Who has access? Surely you want to get hold of the URL and start playing with it. Unfortunately, access is limited to RIICE partners. IRRI, SARMAT, GIZ, SDC, Alliance have access to all the country WebGIS. However, national partners are limited or confined to their own country WebGIS. In fact, Vietnam has 2 WebGIS because North and South don't want to share information. And they don't want others to see what their RIICE is, or RIICE area. So final note, one is the setup issue. It took us about several months to get this straightened out. Before we jumped into ArcGIS server, we were using ArcGIS online because it was free, but we had this issue with images rendering poorly, not to the resolution that we wanted. So even when we moved to ArcGIS server on EC2, even our vendor are also having difficulty setting it up. It's not as easy as documentation and as Google says or Esri says it would be. But once we have that finally ironed out, it was just a matter of putting in data and configuring the interface. Feedback from partners. They are non-technical people. They are very excited. They did not anticipate that you could display or broadcast this amount of information through the internet. Although there are some functions that they want to be included, and we're working on that out. Branding is very important. They want their seal, their logo, their color to be in each individual websites. So we have to work with them and gather all their wishes and see whether we could accommodate. Last note is, can this be done to other projects? Yes, why not? Yes. We're not looking at ArcGIS server per se. There are other tools out there. One of which that is coming around is QGIS Web. And then there's Google Earth or Map API that we could configure. So list of people that needs acknowledgement. If you're not here, pardon me. That's it. Thank you. Before you ask any question, I should request that all questions be confined to WebGIS. Remote sensing, we have experts here. Modeling, we have also experts here, especially for RIICE. So I guess they are the proper person to answer your questions.
Any questions?
Oh, good. No questions. Yes. Nothing more to do.
You said your map is downloadable, right?
Sorry?
Your map is downloadable.
Downloadable.
The maps?
Yeah.
Yes. In a form of shape files, in zip format, as well as in WMS, World Mapping Service.
So that's
Web Mapping Service.
So this is a map. We can get after download. We can get the map data. Right?
The ones that are not considered as shareable, you can download it.
Okay. Another question is when you realize like RIICE is something we can do, something we cannot do, right? How do you estimate the loss or damages from the pesticides, weight, or some other like the noise, some?
Okay, I have to park that question and address it to the proper person, which is Tree. He did most of the modeling outside the WebGIS environment. It's only the product of the modeling that we put in here.
The yield estimates that Tree came up with are using the RIICE version 3, the RIICE 2000 version 3. He's using leaf area index estimates, which are derived from the remote sensing. And that's in the examples where we've run it in 2 sites. The accuracy is very good. For actual yield, it's about 85% agreement at village level and 92% agreement with crop cut observations at municipal level. But when we talk about damage estimates, we're really talking about flood and drought, and we're talking about complete loss. So we use the remote sensing to estimate the RIICE area that was terminally damaged by those 2 events, and then we compute the production for the rest of the area. So we're looking at, when we talk about yield loss and yield damage, we're talking about total loss from those 2 events. And so for the village or municipality, you identify the area that's being damaged and subtract that from your production estimate. We don't look at pest and disease. It's not part of the insurance cover. It's not a multi-peril crop insurance, it's only an insurance against flood and drought.
Yes.
Nice. I'm interested in the approach that you're taking for acquiring or capturing the data from the national partners using a Google Drive, you indicated. Do you have offline functionality? How do you, is the web connection good enough for that? What's your experience with that with the national partner?
Okay, let me cite the Philippine case. Okay, Philippine scenario connection is relatively good once you're near a cafe, internet cafe, or office. What they do is we have this spreadsheet. We didn't use G Sheet for those non-technical people. G Sheet is an equivalent of the Excel sheet, but it's in very well. The reason why we didn't use G Sheet is because once connection is off, you cannot get into the spreadsheet itself, so you cannot enter data. So we ended up using the Excel version. Now the Excel version is stored in the local drive of the one who is monitoring the field. They would encode the information there. At the same time, we have installed Google Drive Sync. Google Drive Sync will upload any information that the our field personnel encodes to the one on the cloud. Okay, so there will be two versions, one in the local drive, the other one is in the cloud drive. The cloud drive we monitor also here at IRRI. And then we set up a server that would collect all of those Excel and store it locally.
So when a person is in the field collecting leaf area or they're collecting yield, are they entering it directly into a device, or is it still hard copies being used? How
Hard copies still, because it's the technology is fairly new or still at infancy stage. The people there are still not used to carrying around gadgets and encoding directly. They are more into paper because it's faster. And then once they're back in their office or in their room, they will start encoding. But we're looking into possible options of utilizing those mobile devices, and possibly through one of our field activity, which is the validation, RIICE and non-RIICE validation. We'll try to use that. Yes.
Just to add, the seminar next week will be from some potential collaborators from the University of Milan. We've developed a leaf area index measuring app for smartphone, so we'll be here presenting that. And if that proves to be a good way of capturing leaf area index, we'd like to integrate that with our field survey application too. So our staff, or the DA field staff, would be able to collect GPS point, photo, LAI, crop monitoring, all in the same app or suite of apps. But that would give you the collection in the field, but we would still upload that data only over Wi-Fi. I think they still have to go back to a Wi-Fi point for that to be sent to our aggregation system. But yeah, come back next week.
Good, thanks.
So connectivity is one issue. Some places where there is no connectivity at all, so it's best just to encode it in Excel. Paper, Excel, then go to a cafe, then it will happen.
Any other questions?
Okay. Thank you.
Thank you very much for attending the seminar and have a great